All right, so this is the second part of collision theory, and I just wanted to spend a few minutes just going over what are the 5 factors that impact the rate of collision. And when you talk about these factors in an FRQ, you want to talk about effective collisions, because that's what it's all about. It's not just colliding, but the collisions have to be effective. So what are the factors that can impact whether or not a collision is effective and therefore affect rate? Well, the first is temperature. We just talked about this. We have a higher percentage of molecules that can break that energy of activation barrier, higher percent, right? Concentration, the more particles I have closer together compared to further apart, the more likely they are to have collisions. Now, one of the things we didn't talk about in the last podcast was the nature of reactants. So imagine this. Imagine I have a reactant that's this big blob right here. This is a biochemical that's found in your body, okay? And let's say that the active site I am trying to hit that has to react in order for a reaction to occur is this red blob right here. Let me see if I can change this color. Let's say it's this red blob right here. Even if I can hit this molecule, let's say there's a small molecule trying to hit it, and I can hit it with enough energy to break the activation, to hit the activation energy barrier, I not only have to have enough energy, but I have to hit it with the right orientation. Oops. My collision is not effective unless I hit it with the right orientation. So the orientation has to be correct. I have to hit it in the right spot. So the larger the molecule is, the less likely it is for you to have effective collisions, and therefore the rate's going to be slower. So the smaller the particles, the more effective your collisions. Okay. The other thing we didn't talk about in the last process is the whole idea of the physical state. In the physical state, if you think about, if I have a solid, let's say an ionic solid, and I'm trying to get it to react, and the red things are trying to react with the green particles, when they hit, they are only hitting the particles on the outside of that crystal lattice. But if I were to pulverize that and make it smaller particles, now it's easier, it's more likely that the red particle is going to be able to hit a green particle and react. So it's a surface area effect. So the solids are much slower, much slower. Gases are going to be faster, right, because those particles are already apart, but they're also very far apart, so it's going to be harder to have more frequent collisions. Solutions are very fast. They're the fastest. This is not quite a solution. The particles are not quite completely ionized, but so the smaller the particles, solutions are going to be faster. And then, of course, the last thing is the presence of a catalyst. What that catalyst does is allows you to get over that activation energy barrier, right? It helps you reach that. Sometimes it does it by giving you an activated complex that's easier to achieve. Okay, so that's going to do it for Part B.